8051 microcontroller has a very powerful instruction set. Unlike in the case of 8085, there is there are additional arithmetic instruction like multiplication and the division, and many more type of features are available in 8051 microcontroller instruction set. So here, first of all, the 8051 has a 1, 2, 3, 4, 5 types of addressing mode. You must be familiar about that, and already you know, I think, about the addressing mode: the immediate addressing mode, register addressing mode, direct addressing mode, register indirect addressing mode, index addressing mode. And the type of instruction are 1, 2, 3, 4, 5. So there are 5 types of the instruction. But there is a variance of each type of instruction, like data movement. And what are the mnemonic, or that is the symbolic name in place of the opcode to be used. So these are the fundamental idea about the instruction. Now, all of us know that means in case of a microcontroller programming, 2 types of the programmings are followed generally. One is called the assembly language programming, which includes the different assembly statements following the mnemonic as well as the associated operands. There are other types of the programming method nowadays, because it is very much difficult and harder to remember all the mnemonics or the assembly commands. That is the syntax of the assembly language. So this is C programming, because the structure of the C programming is very much, or the style of the C programming is very much structured. That means we know the C programming, the C language follow the data type declarations, the main function block, as well as the different functions in place of the subroutine calling, and the idea of parameter passing, how the parameters of the functions will be passed. That is called by reference, called by value. These are the things. So this is the standard style of the NCC. But there are variants of the C like Boltland C and the other type of C. So the micro C, that is the microcontroller C programming, follows exactly in a similar manner. But the difference is that unlike in the NCC, the microcontroller has an inbuilt keyword or data type declarations as well as the standard functions. But a specific given microcontroller, they have the particular header file. So this header file is valid only for a given microcontroller like 8051. But if the microcontroller changes, then definitely the header file is the same, because the header file includes what? The specific function which are designed by the given microcontroller, and that is done by the microcontroller manufacturer. So there is a header file. So that header file must be included at the beginning of the programming body, that is C programming body. In fact, the 8051 also follows the same style of the C programming language, which is called the micro C programming. Anyway, first let us learn about the assembly language programming for the 8051 microcontroller. So these are the summary of the mnemonic. And along the column, these are the type of the instruction like data transfer instruction, arithmetic instruction, and logical instruction, Boolean type of instruction, and the branching. Conditional and unconditional branching instructions are also available. So utilizing all these type of 49 instruction in NCS 51, the standard microcontroller, assembly language programming could be done. These are the example of how what are the type of the instruction against each type of the addressing mode. For immediate addressing mode, a data transfer instruction that is moved a byte data. But in assembly, what is this? It is a specific symbol to indicate that it is the operand. Hash 030 and H is the hexadecimal. If it is a decimal, then it should be a what is called the suffix, that is not subscript, suffix, that is D. If it is octal type of data, it will be O, like that. Anyway, we will use this type of format of the operand, how to declare the operand. Then for register type of addressing, this is the example. That means the content of the register R5. Already it is very relevant to mention again. That means the 8051 has no general purpose registers. Rather, a part of the data RAM can be used as registers. So that's why there are 8 registers, R0 designated by R0 to R7. And these 8 registers are the address of the allocated in the data line. It's data RAM. So if you study the special function register map, then what is the absolute address of the R5, R1, R0? You can understand that then that means the these byte locations can retain the content of the byte content, which can be moved. So in the register type addressing, this is the format. So accumulator, that means the value of the R5 register or a specific location in the data RAM will move to the accumulator. And the description is written on. In case of a direct addressing, this is the style. In direct addressing mode, the address of the data is specified as the operand in the instruction. Using direct addressing mode, we can access any registers or on-chip variables. This into the general purpose RAM, SFRs, IO ports, control registers, etc. For example, the name implies the direct. That means the absolute address in the SFR is written. That is the content of the location 47 or not the content of the location. That means the accumulator is loaded with the absolute byte 47. So that's why the name implies that is the direct addressing. The equivalent instruction in 8085 is MBI, move immediate. Now, what is that? Registers indirect addressing. It is somehow, that is the index addressing in case of 8085. So move a @R1. Now, whenever the prefix is given, means the content of the R1 will hold the content in a byte content, and prefix means the content of the memory location as indicated by the R1 registers. So that's why the name implies that means indirect addressing, register indirect addressing. So content of the data RAM location, the address of which is retained by the R1 register, will move to the accumulator. Try to understand. @ symbol indicates that the addressing mode is indirect. If the contents of the R1 is 56H, for example, then the operand is in the internal RAM location 56. Clearly it is no confusion about that. If the content of the RAM location is 56 is 24, then the after execution of the instruction, the 24 hexadecimal byte will be moved to the accumulator. Only R0 and the R1 are allowed in the indirect addressing mode. For example, there are 8 general purpose registers designated by R0 to R7, out of which only 2 registers, that is R0 and the R1, are allowed for register indirect addressing. So what is indexed addressing mode? Whenever the suffix symbol will appear, then it indicates the content of some locations, and the location address is specified by the registers. But here, in case of an index addressing, not only the registers but also the accumulator content may be used as an addressing. Plus the data pointer DPTR is a byte register. So the accumulator plus the DPTR, the sum of which the base address generally is written by the accumulator, the base address is generally written by the DPTR register, accumulator or any registers can be used so that the content of the memory location as indicated by the A plus DPTR will be moved to the move C A, move C. That is the instruction, special instruction. So not move. Whenever we use the index registering of the move C, it will be move C. So these are the type of the instruction. Then what are the other features? That is the types of the instruction in there. 8085. Already it has been listed, summarized previously. There are 49 type of the instruction, which include the different types of the instruction like data transfer, arithmetic, logical, 1, 2, 3, 4, 5 types of instruction. So total instruction is 49. You count. How many instruction in case of 8085? That is 74 or 76. Anyway. So this is about of the type of addressing and the example. Now specifically data transfer instructions include this type of group: move C, move X. Why move X? That means we have discussed, that means that there are two types of the program memory. One is the inside on chip, another is the external program memory. Whenever any data or content should be moved from the external memory, then it will be move X. But move indicates the data transfers taking place from inside program memory locations or data memory locations. So push is a data transfer, but it is a special type of data transfer instruction. That means whenever there is a necessity, especially during subroutine calling, the content of the GP registers or the memory location must be saved to the stack memory. So push and pop are used as a data transfer instruction associated with the subroutine location memory location, that is stack memory location. Then there is an XCH, XCHD, the two special type of instruction for swapping between the general purpose register, DP registers, that is R0 to R7, as well as accumulator, etc. So these are the format. These are the format, including all type of the instruction. What is the length of the instruction? That is also given. How many machine cycles the instruction required? That is also given. So you can check which instruction is more powerful. That is speediest. That is indicated by the number of cycles, or many cycles. You can see only 2 machine cycles are the highest number of the machine cycles. But one machine cycle may include the number of T-states. So T-states is the fundamental timing unit that will depend on the clock rate or clock speed. But the number of bytes associated will be required regarding the including the operands is given by this. So here also only not 3 but only 2 bytes are the maximum length of the instruction. That will depend on the nature of the instruction. So these are the arithmetic instructions. At C, add, or subtraction, sub B. At C means add with carry, sub B means subtraction with borrow, increment, decrement, and mul-div. These are the 2 additional instructions offered by the NCS 51 microcontroller, because there is a multiplication with a byte operands as well as 16 byte 16 bit by 1 byte operand. What is the format and what is the each type of the, that is what will happen after execution of the mal followed by the operand, which is given by this mal and the div. Here the instruction is mal AB. That is, it will multiply the A content of the A and the B registers, and the result will be stored to the accumulator A registers in that format. In case of a div, what will be the dividend and the divisor? Dividend will be the content of the accumulator A, divisor is the content of the accumulator B, and the remainder and the quotient will move to the accumulator. And the B registers, after the executions of the div, B registers will hold the remainder if the result is not perfectly divisible. So the quotient and the remainder can be directly obtained by the executions of this instruction. The number of cycles for the mal and the div is the highest, that is 4 machine cycles. Otherwise, the bytes is, that is, number of bytes for the instruction is this, only 1. So DA is a decimal adjust for addition, or decimal adjust the accumulator. So it is a single byte instruction, DAA, and the machine cycles is 1. What the DA will do, that means if the number is in the binary or the hexadecimal format, it will be converted to the decimally, after decimally adjusted, so that the content will lie in the range of the 0 to 9. So it is in the form of the BCD, binary coded decimal. So among the logical instruction, these are the logical instruction. ANL means ending, logically ending. ORL means logically ORing. XRL means exclusive ORing. Clear, complementations. Now here there is another powerful feature. That means in case of 8085, only the content of the accumulator can be complemented by the instruction CMA. But here it is possible to complement the content of the operand, that may be a register content, accumulator content, or memory locations directly. So this is RL, left, rotate the content of the operand left direction. This is RLC, rotate the content of the left direction via carry. This is RR, rotate the content of the operand, any operand. But in case of 8085, it was only the accumulator, like RLC, RAR, etc. But here, this feature is allowed. That means the content of the byte locations, that byte can be a memory location, that can be rotated. RLC and the swap is the direct interchange of the two operands. And these are the summary. The following table shows the all possible mnemonics of the logical instruction. So what about the Boolean instruction? Boolean or bit manipulation instruction? As the name suggests, Boolean or the bit manipulation instruction will deal with bit variables. For example, CLR. One thing should be remembered here, a very powerful additional feature, that means the instruction will operate bitwise as well as the bytewise. That will be clear whenever we give the examples, different examples. Set bit, move bitwise, that is not the data transfer, we will give some example. Jump, if carry is set, jump if carry is not set, JNC, JB, JNB, JBC, ANL, ORL, CPL, so these are the logical instruction. Not logical, Boolean type of instruction. And this is the summary of the machine language, and this is the summary of the detail, the number of cycles, number of bytes, etc. This is the program branching instruction. There are variety, ample of variety in the program branching. For example, in case of 8085, there is only a jump instruction. Jump followed by the address level. So that address level must be the valid address level within the 64 kilobytes memory map. But here there are three types of the jump: L jump, long jump, absolute jump, and the short jump. So what is the difference? That means in case of a L jump, long jump, the range of the branching from that locations where the jump instruction, L jump instruction reside will be 64 kilobytes within, plus minus. In case of an absolute jump, anywhere it can be jumped. In fact, this is similar. But for L jump, the address range reference to the locations where the jump instruction, L jump instruction reside, it only will be plus minus 128 bytes. So that's why the name implies the short jump. If the address level is out of range, but the programmer will use the sjump instruction, then the compiler will give the error. It will check. JZ, JNZ is a conditional branching instruction. This is very powerful instruction, additional name CZNE, TZNE. What is CZNE? That means jump not equal, that is for a signed number, when the carry is set, otherwise not. TZNE is a special type of branching instruction associated with a zero flag. That means decrement the operand until it becomes zero. Decrement the operand, branch to the when the zero flag is not set, that is zero. And after branching, decrement the operand. Ultimately, this is a loop type instruction. TZNZ. I will give the example, otherwise it will not be clear. Return is the end instruction of the subroutine calling. But there are two types of return. One is called the RET, normal subroutine calling, but this is return I. We have discussed during the interrupt service routine processing, that means ISR is a special type of subroutine. It will be invoked by the processor whenever any valid interrupt request will occur. That interrupt request may be a software interrupt request. That interrupt request may be a hardware interrupt request. But the terminating instruction from that ISR interrupt service routine will be return I. So that is the difference between the RET and the return I. Try to understand. And these are the table which includes the types of the instruction. Now we are in a position to give illustration about the assembly language programming. So if you have any questions about the instructions of the 805 and what are the difference in respect of the 8085, you must be able to understand well. This is the body of the assembly language programming. So any operand, absolute operand should be suffixed by the hash. The form is like that. The assembly statement followed by the semicolon and the comments or remark. So what is happening after execution of the instruction, that must be under remark, like that. So simple data movement instruction. And what will happen after the execution, that is also written. You can follow the data movement and the additional. And these are the power or the characteristic of the assembly language program. What the assembly language instruction includes, that is very much important. stepwise. You can follow this note. In mnemonic, abbreviation easy to remember. The comments to the CPU telling it what those to do with those items. Now, in assembly language programming, so this is some extent of the high language programming. The microcontroller CPU cannot understand until and unless this programming language will be translated to the machine code. The machine code is a binary bits of 1-0 string. So microprocessor can only understand the mnemonic when it is translated or assembled by the 1-0 string. But what is that? There are some instructions which are not the CPU instruction, but these are the instructions meant for the assembler which are used. So there are different types of the assembler. All assembler, there are the instruction, or rather it is called the directives. So assembler includes the directive. For example, the ORG0. That means start origin at the 0 locations in the program memory. So the following codes must lie from the 0 location, X location. If any other number is written, then the following body must lie from that location as specified in the ORG directive, origin. The last directive will be end. If end is not used, then how the microcontroller assembler will know whether is any instruction is pending or not. That's why between the ORG and the end, the assembly language statement will be given. So these are already explained here. And these are the states of the assembly language program are outlined. 1, 2, 3, 4, like that. And this diagram is very much important for those who are writing the program in assembler. That means whenever we write this assembly language program, there must be editor. The editor is available with the assembler software. So edit the program. The extension of the assembly language programming by standard will be .asm. So editor program, when the program is written or edited, it will be saved with this type of file name, formatted file name. Then there is a commander option. It will be passed to for assembly of the edited program. So assembly program is assembly program will consist of the 3 different types of the program. At least 2 different types of the program. One is called the .lst file. Another is called .obj file, object file and the listing file. There may be other type of process reference file which are optionally needed for a good assembler. So what is the purpose of the .lst file? That means whenever there is any syntax error during the assembly, that will be noted and that will be specified in the list file. As well as we'll show that in the list file contains the machine code and the absolute mnemonic with respect to the locations. So .lst, .obj, that is the output from the assembler program or assembly part. But still, this file could not be understood by the CPU till now, until unless it is converted to the absolute machine code by the linker program, the third step. In fact, the linker program again basically will produce the output .abs, and there is an intermediate state so that a machine code file, generally the microcontroller microcontroller assembly language program will generate the machine code file with an extension of .hex. Why? Because all the codes are expressed in the hex file. And these are the written. The list file, which is optional, is very useful for the programmer so that the programmer will be able to rectify the syntax error. It lists all the opcodes and the addresses as well as error that the assembler detected. The programmer uses the list file to find the syntax error or for debug or debug. So this is the format of the .lst file. You can see the first column is the absolute address, and the next column is the machine code. The CPU can only understand this machine code, and the last column is the edited assembly statements in between org and the end directive. So this is the complete picture how the source program or the editor program in assembly language can be compiled to machine code. But still, this type of program, this machine code should be extracted. How? By linking the program that in the linker program, so that the hex file will include Intel hex file will include the link file. I will show what is the format of the hex file. Yes. Intel hex format. You can see the hex file format looks like this. There is a line number. The first thing is a 4 significant places, decimal places indicate the address location. After that, the series of the byte, hexadecimal byte, will be there. And the last 4 significant digit is not the byte content, but is a checksum. What is meant by the checksum? Those who are familiar about the types of the error in the digital electronics, cyclic redundancy checksum, CRC error. Then the summing the all bytes, hexadecimal bytes, and that will be converted to the 16-bit error code that is called the checksum. So line wise, the first 4 digit indicates the absolute address in the hexadecimal, followed by the number of bytes from that to that location. So how many bytes are there? In fact, 16 bytes. Each line consists of the 16 bytes, 16 hexadecimal bytes. After that, the 4th digit will be the hexadecimal number, that is the checksum. These will go on line by line. Okay, and ultimately it will be the last line will be like that, so that this is the link file with the Intel hex format. This is called the binary or Intel hex format. And the microcontroller, whenever the linker will upload this program to the microcontroller program memory by special technique, that is binding the program, then except the starting address should be found out. After that, byte by byte, the program locations, program memory location will be burned to these bytes, but not the checksum. Checksum is for internal use of the linker, so that the last byte will be burned to the program memory. So that is the Intel hex format, and the linker will generate the Intel hex format during assembly code. During assembling the complete program, there are so many types of the different types of the assembler. You must be able to learn in laboratory classes. That means it's a KEIL compiler, KEIL, so that the KEIL compiler will deal about the microcontroller program like MCS51 microcontroller, as well as a VR microcontroller, Atmega microcontroller. So that means standardized by the Atmel Incorporation, the name. So they have introduced the KEIL compiler. By using the KEIL compiler, the simple MCS51 assembly language programming can be compiled and the linked. So I will give the demo later on, how the KEIL compiler can be used. So this is all about the laboratory tips for following the program instruction. Anyway, better we will repeat the types of the program as a practice. What are the types of the program? How to write the program? Better, before that, we must discuss about this type of DZNZ, a special type of conditional branching instruction. Jump, loop, and the call instruction. Now, what is that? DZNZ will proceed the name of the register, comma, and the address level. The register is decremented if it is not 0. It jumps to the target address referred by the address level. Prior to the start of that is a looping automatically feature. Prior to the start of the loop, the register is loaded with a counter for the number of repetitions. Counter can be R0 to R7 or any RAM location. As for an example, DZNZ R2, that is why R2 registers can be used. It is decremented after each jump. Where the branching will occur? Again, this location. So automatically the branching will occur here, but not one time. It will be branched until and unless the content of the R2 will be 0. So repeat until R2 is equal to 0. So how many times the branching will occur? 10 times. Why 10 times? Not 10 times, that is in decimal it is 10 times, because if we write capital H, it will be hexadecimal 10, otherwise it is decimal 10. So initially the R2 has been initialized by the decimal number 10, but again it will be decremented by this branching instruction. How many times? Automatically, that is 10 times. After 10 times decrementation, the content of the R2 will be 0. No branching will occur. So control will pass to the next instruction, that is this. So this is a special type of the branching, branch with decrementation. Similarly, CZNZ is what? The branching will occur, that is the calling, subroutine calling. C stands for the subroutine calling. So subroutine will be called repeatedly. But here, only the simple branching will occur with the absolute address repeatedly. So this is a one type of program, but it loads the accumulator with the value FF55, complement the SEC to 700 times. How? Like this. So there is a nesting. There is a nesting of branching. That means, first of all, the R2 will be decremented until and unless it becomes 0. Then there will be another decrementation by R3. So within each decrement of this statement, there will be multiple times of the decrementation. So repeat it 70 times for R2. because R2 value is 70. But R3 is 10 times. That means what will be the net type of the branching? 70 multiplied by the 10, that is 700. So that's why the complementation will be done by the nested degen statement, nested branching with 700 times. We can further increase the decrementation if we use another type of register, NZR4. So second level nesting, this is the first level nesting. So these are the use of the branch statements. So you must go through this programming statement for this chapter. Then you'll be able to write the complete program according to the given problem. What are the program that I'm giving the program type of program now. So these are the programming example, simple programs. Extend the content of the location FF, H and the FF00. How to write the program. So I will discuss. Data pointer will be loaded by this statement. Then get the content of the 00F0 in A. But we have used the MOVX. That means, according to the statement, internal as well as the external memory locations are used. So that's why from the external memory location, the address is this. Now save the content. That is, save this absolute byte to the R0 registers, and the content of the accumulator, which has been already saved from the external memory location, will be passed to the R0 location. Move A to 50 or like that. Then again, the externally it has been changed. Again, the content will be moved to the external memory location as indicated by the DPTR. So these are the assembly statement. Transfer the 30 hex to external location 1020 because external location is 64 kilobytes. External memory size is 64 kilobytes. During memory organization, I have discussed that means how the external memory can be interfaced via the port. So that means internal data, that is the content of the internal data block 20 to 30. How many bytes? 30 minus 20 plus 1. The block of data bytes will be saved to the external location 1020 through 1030. That is the purpose of program. Here we have to transfer the 10 data bytes from the internal to external RAM. So first we need one counter. Thus we need two pointers. One for the source, one for source second, one for source, second for the destination. How? This is the counter value. R7 JR power register has been set to the counter value 0A, 10 decimal. R0, the initial source location, that is 20. What is 20? That is internal data RAM location. That is set to the R0. Then the DPTR register should be loaded with another source location, external source location 1020X. Then this is get the first content in the accumulator. So internal RAM location 20 will be stored to the A, and the content of the accumulator will be saved to the external memory location as indicated by the DPTR. Now, the next memory location will be available by incrementations of the R0 as well as the incrementation of the DPTR. And this will go on by the JNZ R7 next. So automatically by using the instruction, the same type of the instruction, the instruction as the NXT is the address level lies here, it will be executed repeatedly by the looping instruction. And after that, the program will be terminated. There must be terminating instruction. There is no as such the halt instruction, but it is an assembly language instruction. So there will be an end statement or like that. So try to understand how the block of the data transfer has been implemented using the assembly statement. So there are so many examples. Find out how many equal bytes between the two memory blocks, internal RAM 10-0 to 20 and 20 to 30 are available. That means how many equal bytes. It will check the content of the range of the internal memory, that is 10-0 to 20 and 20 hex to 30 hex. So how many bytes are equal? The equality condition. And the count will be set to the A memory location, number of counts. So these are the total program. These are the assembly language programming example for your practice. I will give you the list of the program so that you can go through the instruction and then write the practice. This is for simple mathematical or logical operation. But for interfacing, there is a little bit of complicated program. For in writing the programming for interfacing with a different device, peripheral device, you require the knowledge of the devices to be interfaced. Now, that is the first task. But what about the micro C programming? This is the nature of the micro C programming using C language. The first statement is the header file inclusion. So for MCS51 microcontroller, this is the header file, name of the header file, reg x51, reg x52.h. Why? That means the specific compiler will look for the different address for the peripheral in the SFR from this header file. So this header file, that is the .h, is the header file in C that must be included. Then inclusion of the header file, the main program will start with the argument void, because main has no feature, main has no data type. You know what is the simplification of the void. So these are the new P0, P1 are the exact name of the register, that is IO port. So P0 and the P1 are set to 0. What is the meaning of it? That means whenever all the ports are set to the output mode. That's why that is initialized by writing this statement, C statement, assignment statement. When any port should be set to 01 means it will be input port. Next, these are the port assignment statement. That means P1 port, the content of the P1 port should be set to the output port by writing this statement. P3 is equal to P1. Then there is an conditional infinite looping statement. While with a argument, a number, not condition. So go to infinity, that means there is an infinite loop. To stop the process here, if there is no infinity loop, then we can write the program. And the program will end to this thing. That means this is a simple C statement body. The purpose of the program is to program any port to be set as an output on 89C. It is a variance of the MCS51 microcontroller like this. The same above code can be written in the assembly language likewise. So this is the assembly statement, this is the C statement. You can see the number of statements will be very, very small, but the number of statements in the assembly language is large. So you can go through this programming example in assembly and the C. So C programming is a very efficient programming. That means it improves but the number of byte size may be larger after compilation with respect to the assembly language programming. But the number of statements will be very much reduced when you write the program in C. So these are the example. This C notes will be distributed. You try to go through this language. These are Keil programming, and I can show you how the Keil can be used. That is like this. So Keil Microvision is the name of the software. After installation, it will appear as in this icon, Keil Microvision. Assembler. Version 5. So this is the Keil Microvision ID. ID means Integrated Development Environment. So the Keil installer, if you have the Keil installer, you can install in your machines and you can go for practice. The first task is to create the project, new project. The project file extension is automatically set. So new project. I'm opening and creating a new project. And save. Then it will ask for the type of the processor. I think Atmel. Device, the name of the device. 89 or Atmel. Yes. Now the Atmel has been incorporated with a microchip incorporation. That's why it shows the different types of the devices of the microcontroller appear under microchip. For example, we will select 8051 or 8951. So 8089C51. Select. Copy startup A51 to project folder, automatically it will input. So here a project folder has been created by the name PAL, and this is the empty target, no target. Under the target one, the different list file, compile file, link file, hex file, that will be stored after different processing. Now, what is the task? New file. New. Will appear. Here you will follow the assembly language program, following the directive org and int, the body of the assembler. And you must same. So I am copying one such file. Like C program. Already written, the name of the program is toggle.c extension. But assembly program you will practice using the KL compiler. So now the last task is to build or compile this C program. Where হ্যালো, আজকে একটা ক্লাসে আছি, দেখছি আমি তোমাদের বলছি, ক্লাসটা যদি শেষ হয়ে যায় ঠিক মতো তাহলে মেসেজ দিয়ে দেবো। ওকে, আচ্ছা, এই 7টা নাগাদ শেষ হবে দেখছি আমি, ঠিক আছে? ওকে। F7. Save change to text? No. Okay, yes. So this is the output of the file whenever we build. How the build program will build, that means suppose I am opening the existing project like this. So these are the output after building, that means then you will get the other type of format. So this is the output of the building, linking, everything will be done, program size is like that. Build time elapsed, that means a number, no error for this C statement. So this is the output, and then the program should be debugged by single C statement. And here all the maps of the hardware peripheral will appear. So that is a separate task I will discuss in the next class. Okay. So that is the final. Then create the project, edit the program, create the project, then select the microcontroller device, then edit the program, then save the program, then finally F7 or this will appear as a grid. The project, the build will be like that here. F7, that is a short key. Rebuild is there and build is there, F7. Build the target file. So you can run the hex file. The hex file is not source group. That is the type of the extension, that is hex. the type of the extension that is. So yes. So if we click the target, then the compiled file error that will appear. This is the compilation. Because there are so many components in under Kale. One component will do one thing. So this is the object file. And it can be listed to the absolute memory map for this statement. The symbol used, the range of the statement. That means this C program that has been assembled with the assembler statement. That is the purpose of using the building the file. But there is an hex file will be created also, the .hex, so that the what is the absolute code that will be also available. Anyway, if you have the Kale compiler, or you can share, I will give you the link address to the Google Drive, the installer of the Kale that you can install. But better you can use, but better I suggest for programming practice initially use the simple simulator like this. This is the simple simulator. You can write the assembly statement, you can assemble, simulate, debug this statement. So this is available also. How? This is available with the simulator Win8051. So Win8051 I can send you via your group mail ID, you can install to a machine. It's very simple. So many simple 8051 simulator are available. So this is Win8051 simulator. Okay, so this is the purpose of assembly programming and simulation and test for testing purpose. Simulation, the purpose of simulation is of two types. One is for that means whether any syntax error will appear or not, that we must remove, and then after compiling the program, assembling the program with an error-free, that with error-free, no error, you run the program with the debugging feature of the simulator, so that you can run the program with the debugging feature, and ultimately you will be able to gain knowledge or familiarity about the 8051 program. Thank you. So I think now, if you have any question, then ask. Because assembly and programming requires the knowledge of the software only, the steps. Hello. If you have any questions, have you understood? Explanation. Okay. So I will be sending your Win8051 simulator RAR file and the class notes. So thank you for today's attendance. I'm ending now.